Have you ever stopped to think about the insane amount of data we create every single day? Every click, every photo we upload, every show we stream, it all adds up to this unbelievable digital flood. So how is it all managed? I mean, how do the giants of the tech world, your Googles, your Netflixes, your Amazons, thrive in this storm of information? How do they possibly manage this digital tsunami and turn it into something useful, like knowing exactly what movie you want to watch next? Well, the answer is a concept called big data. But it's not just about having a lot of data. The real challenge, the thing that defines it, comes down to three core characteristics: the sheer volume, the incredible velocity, and the complex variety of it all. So let's dig in and break down what these three V's actually mean, because they're at the heart of the entire big data challenge. First up is volume, and this one's the most obvious. We're talking about an unimaginable quantity of data. Not just gigabytes or terabytes, but petabytes, exabytes, and even zettabytes. It's just a mind-boggling amount of information that needs to be stored somewhere. Next, we have velocity. Data isn't just sitting still. It's a roaring waterfall of information that never, ever stops. And for it to be useful, it has to be processed in real time or near real time. And finally, there's variety. You know, data isn't all nice and tidy in a spreadsheet. It's a messy combination of everything. You've got structured data, sure, but also unstructured text from emails, photos, videos, sensor data, and figuring out how to handle that chaotic mix is a huge, huge challenge. Okay, so you have this massive, fast-moving, and totally messy flood of data. How in the world do you actually process it? Well, that brings us to our first major solution, a really powerful framework called Hadoop. So what is Hadoop? In simple terms, it's a system that was specifically designed to solve the big data problem. Instead of trying to use one gigantic, ridiculously expensive supercomputer, Hadoop uses a whole team of regular computers, all working together to share the load and process enormous datasets at the same time. At the heart of Hadoop is something called HDFS, which stands for the Hadoop Distributed File System. Instead of trying to save one giant file on a single machine, it does something way smarter. It chops that file up into smaller blocks and spreads them out across all the different computers in the cluster. This not only makes it possible to store huge files, but also keeps your data safe if one of the machines fails. But how does Hadoop actually process all that data? It uses a really clever model called MapReduce. Think of it like this. The map step is like going through a giant pile of Lego bricks and sorting them all by color and shape into different buckets. Then, the reduce step is where you summarize all that work. You count how many red bricks you have, how many blue ones, and so on to get your final answer. It's a simple idea, but it's incredibly powerful at scale. All right, so Hadoop is the engine that processes the data. But where do you actually store it? It turns out traditional databases just weren't built for the variety and scale of big data, which led to the creation of a whole new toolbox. And that's where the world of NoSQL comes in. It stands for Not Only SQL, and these are non-relational databases that break free from the rigid tables and rows of the past. They offer the kind of flexibility that modern, messy data absolutely demands. This simplest type of NoSQL database is the key value store. The concept here is incredibly straightforward. You have a unique key, like a word in a dictionary, that points directly to its value, which is its definition. It's fast, it's simple, and it's super easy to scale. So you can see here, a customer ID acts as the key, and all their information is just stuffed into the value. This direct lookup method makes getting that data back out incredibly fast and efficient. Next up, we have document databases. These take that key value idea and kind of put it on steroids. The value in this case is a flexible, self-contained document, usually in a format like JSON, that holds all the data for a single item all in one place. So instead of just a long string of text, all the customer's information is neatly organized with labels inside the document. This structure makes the data way more flexible and much easier for developers to work with. Now this next type is really cool. Column-oriented databases. Instead of storing data in rows like a traditional spreadsheet, they store it in columns. This might sound like a small change, but it makes them unbelievably fast for analytics, like when you need to analyze one specific piece of information across millions of records. With traditional row storage, if you wanted to get all the last names from your table, the database would have to read through every single piece of data in every row. But with column storage, the database can just go and grab the last name column all in one go. It is a massive game changer for speed. And finally, we get to graph databases. Now, these are totally different. They're not about tables or documents at all. They're built for one very specific, very important purpose: to map and understand relationships. Here, data is stored as nodes, which are the things, and edges, which are the connections between those things. Think social networks or fraud detection systems.
You can see it right here. Each circle is a node. It could be a person, a product, a place, and the lines connecting them are edges, representing relationships like is friends with or likes. This structure is literally built to answer questions about how everything is connected.
Okay, that was a lot of theory. But how does this all actually work in the real world? Let's take a look at a couple of popular databases to see these concepts in action. First up is MongoDB, which is one of the most popular document databases out there. Fun fact, its name actually comes from the word humongous because it was designed from the very beginning to handle huge, scalable datasets. It's an absolute go-to for things like storing flexible user profiles for websites and apps.
And this right here is Neo4j, a leader in the graph database space. What you're seeing isn't just a bunch of data in a table, it's a visual map of complex relationships. Here it's showing which members have reviewed which restaurants. This is the incredible power of a graph database in action. So, from the 3 V's that define big data to the processing power of Hadoop and the flexible storage of NoSQL, we now have the tools to manage this digital tsunami. But the thing is, the flood isn't stopping. Our data is only getting bigger, faster, and even stranger. And that leaves us with one final thought. What do you think the next solution is going to look like?